Hi there, and welcome to a practical guide to SSH. I wrote a companion article for this video, so if it is all helpful and you want to follow along, this goes into a little bit more detail and has some diagrams, some code snippets, etc. I'm making this video mainly geared toward my colleagues who tend to be undergrads or grad students who are working in machine learning and have maybe interacted a little bit with SSH, but have not had a very principled understanding of how it works. What is SSH, or secure shell? I think a good place to start would be, what is a shell? So a shell is a textual-based interface where you can run commands, interact with the operating system, run programs, etc. So what I have in front of me right over here is a shell. Specifically, we're running bash. That's not critically important, but yeah, on Mac OS, the default shell is ZSH or Z shell. On Linux, it tends to be bash, and then on Windows, it tends to be PowerShell, which most developers, the first thing they do is install git bash so they can run bash instead of PowerShell, because that's the go-to shell that basically all documentation is written for. So yeah, what can you do from a shell? Well, basically everything. If I had a Python program, I could run python main.py. I could interact with the operating system. I can see what's running on it. I could launch an SQL server. I could do any number of things. When it comes to machine learning or web servers or for databases, you tend not to be running it on your laptop at home. You tend to be running it on some far-off server. So how do you connect to the server and make changes or launch things or debug or connect to the server with a lot of really powerful GPUs so you can launch a training run? Well, that's what SSH is for. SSH allows you to run this shell on that server as if you were standing right in front of it and were connected to it directly. One thing to note is SSH is a protocol. So like HTTP, TCP, other Ps, it's a way for computers to communicate between one another. And so there's SSH, the protocol, and then there is SSH, the programmer, the client. So yes, this is the real website for it, but OpenSSH is almost synonymous with SSH, the protocol. It's installed by default on Mac OS and on Linux, and apparently now it's being installed on Windows as well, but it used to be the case that you had to install some other SSH client, such as PuTTY. So whenever we're using SSH or ssh-keygen or SSH agent or SSH daemon, SSH whatever, we are essentially using one of the services from OpenSSH more likely than not. So now that has been noted, whenever we're running SSH, we're actually running OpenSSH and their specific implementation of it. So how do you start with connecting to some remote computer? Well, one way you might be able to do this is you say, I want to log on as some user. Say it's root, you want administrative access. And so you say, I want to log on, let's say SSH root. So you have the user, and then you have the IP address like 1234567 That's one way you can use SSH. But this tends not to be the normal way. This tends to be less secure, it's also less convenient, and there's a bunch of other different structures around SSH that don't really use this. But nonetheless, it is valid. But we're going to be going over the more common way to use SSH, which is with a private key and a public key. The private key is it's your password and your username wrapped into one. It is private ID that identifies I am Gatlin. That you want to keep secret. And then you have your public key. Your public key is able to confirm that someone or some computer has the private key. So you'll take your public key and you'll drop it onto some server that you want access to. And then when you try to connect to that computer with SSH, it will see, oh, someone's trying to connect to this with SSH. Oh, and they provided their private key. Let's check this private key against these authorized keys. And then we'll see, oh, there is a public key here for Gatlin, and this private key seems to match it. And so it'll be like, well, welcome in, Gatlin. You can now sign on as the administrator of this computer and run whatever you need to. And that's what we're going to be working on here. And let me note, this is also specific for Linux or Mac. And if you want to follow along, you're going to either have to use Windows subsystem for Linux or git bash if you're using Windows. A very common place to put text configuration files, including if you're using VS Code, your VS Code configuration files would be inside of your home directory, and they are preceded with a dot. So dots mean that these are hidden files. Your average Joe is not meant to see them and probably shouldn't be messing with them. So if I just do normal ls, you'll see it says the directory is empty. But if you provide -a, then you'll be able to see all of the, what they're called are dot files or dot folders. Anyways, so OpenSSH stores their configuration files under .ssh. And since OpenSSH has become the go-to standard SSH platform. Everything that uses SSH will also tend to look into this directory for the default configuration. We don't have an SSH folder, so we're gonna go ahead and make that. Make the directory .ssh. Cool. We have the folder over here. We're gonna go ahead and change the permissions as well. So we're gonna change this to 700. Why are we doing this? SSH keys, again, they're kind of like your passwords. You don't want anyone to have access to them. This is a shorthand for who you want to give permissions to. This 7 is the owner of this, can just like do everything normally, but people who don't own it, or even the public, they're not allowed to do anything with these files. Do ssh-keygen. And again, this is an OpenSSH utility. And when we just run it, we are doing so with all of the defaults, right? So it's gonna pick a default encryption algorithm to generate your private and public keys. In this case, it chose RSA. And even if we weren't in .ssh, it would want to save it into .ssh. We actually don't want RSA. RSA is an older algorithm, and the more modern one is, I think it's ED215. It will autocomplete for me, but ssh-keygen, and we can specify the type of encryption by doing that, and then it's ED, and then I went hit tab and auto-completed for me. If you don't provide any kind of file name, it will automatically save it as ID underscore whatever the encryption is called. So I'm just gonna go ahead and do that. It's gonna ask if I want to add a passphrase. So passphrase means every single time you use the key, it's gonna ask you to type in a password. So this is helpful in case someone gets a hold of your computer and they're able to extract your SSH key. I'm gonna go ahead and skip over that. And this right here is just like a random art image. So this is just a nice way to be able to compare like 2 different key files and see if they're the same. Instead of having to compare long ass strings, you can just kind of like glance after generate 2 random arts and just be like, yep, these do not look the same. I'm gonna go ahead and cd into the SSH directory, and we're gonna list all the files. And now we can see we've got our key files. So this right here is the private key. The private key doesn't often have a file extension, and the public key almost always ends in pub. But the private key can be named a .key, or it can be named or it can be like PPY, or no, PKY, something like that. And we're gonna go ahead and read these out real quick. So you can see this is the private key. I'm not modeling good behavior right now because I'm printing it out and showing it to you guys, but I'm not going to be using this key for anything. So it doesn't really matter. But normally you want to keep this private. And then we have our public key. Our public key looks a little bit different. Remember, this is the one we're going to be giving our servers to say, like, we authorize anyone with the private key corresponding with this public key to access this computer. You can see it starts with the encryption algorithm with the key itself. And then you'll see like this thing after it. This is the comment on your key. By default, it's going to say user, computer name. We want to connect to some kind of computer. I'm going to go ahead and demonstrate this by using RunPod. Again, SSH works on anything. You can set it up on any computer. It's very common, though, for machine learning people to use some sort of cloud compute framework. This isn't necessarily platform specific. Remember, we want to give our server our public key, so we can say like, oh yes, we authorize whoever has this private key to access the computer. So most cloud providers will give you access like a web terminal. This is like a poor man's SSH. You're limited by the fact that you're in a browser, and you also can't run other programs that are built on top of SSH, for example, VS Code Connect. So yeah, we want to give RunPod our key. So what is Linux using to manage SSH connections? Well, it's using OpenSSH. And so we want to change a configuration and give it some sort of public key authority to connect with a private key. Where do we do that? If you said home.ssh, you'd be right. Only this does not exist yet, so we're gonna have to do the same thing we did before. How does it know which public keys to accept a connection with? That's done through an authorized keys file. We're gonna go ahead and create an authorized keys file. So now we have authorized keys. If I read it out, it's empty. So now we want to add my public key to it. How do we do that? Well, I'm gonna go copy my public key here, and I'm going to run this command. So echo, and then we can use this operator here, which will take whatever the left-hand side's output was and append it to a file. So in this case, we want to append it to authorized keys. And if I cat authorized keys, we can see it now contains my public key. Great, so at this point, we should be fine. We should be good to go. We should be able to connect. So how do we use this? First of all, SSH, we have to specify where we're connecting to. So I'm gonna go back to RunPod. We can see we're connecting as root. This is very common. And then we also have the IP address here. Great, so we're gonna connect a root to this IP address. We also need to specify the port. So typically when you're running SSH, the default port is going to be like 22. So usually you'll connect to 22, and if you don't specify a port here with the -p flag, it will default to 22. And within RunPod's internal network, it is 22, but then when they port forward it, you're connecting to just the RunPod network, you're going to be connecting with this port here. So we're connecting to that port. Great. Lastly, we now need to specify the private key we're using. The -i here means our identity file. That's another name for the private key, since it is like your ID. It identifies me. It identifies Gatlin. So we got this all put together. And sometimes you might need to change this depending on what you named your key. Uh-oh, connection refused. We get an error when we try to connect to this machine, even though everything should be fine. So something important to note is that there has to be something on the computer we're trying to connect to that will listen in for us trying to connect. That's called the SSH daemon. The SSH daemon isn't started up automatically, and it doesn't use the authorized key file yet. So when I run service SSH status, I'm trying to see if the daemon is running, and it says sshd is not running. So we will go ahead and, well, we would start it, but there's actually a few more configuration files we need to set. Public key authentication, we're gonna go ahead and uncomment this. We want yes on this. Where is it? Authorized keys file. So this is the default place to put it, and we're gonna save this. Oh, we have to generate the SSH keys. So I'll show you why the server you're connecting to also needs to have their own SSH keys. This generates all of the private and public key configs that are needed. So you see all the encryption algorithms. You got RSA, DSA, ECDSA, ABCDEFG, and ED over here. And you can see they're all created right over here. So now that we've generated the new host keys, everything should be ready to go. So we start up SSH service. Awesome, it started up. So now let's go ahead and try again. We can see here that it is asking if we would like to continue connecting. So this is where the host keys come in. The server isn't really connecting to anything super harmful. Why does it need SSH keys? And the reason why is to protect against man-in-the-middle attacks. We're gonna go ahead and say yes on this. Great, and then we are connected. We now have a new file inside of our .ssh directory, and this contains all of the known hosts. A few of the keys here, I believe, are a mix of the proxies that are in between us connecting to the actual server, because we're actually going routers and other computers on like the RunPod network. So now we will not get that message of do we want to trust them, and then we get connected. We don't have to answer it again. So we have successfully connected to our server. There's just one issue. And that issue is that this is annoying. It is quite annoying. And especially for connecting to a bunch of different computers, you don't want to have to, okay, what port is it on? What is the IP address? Which user am I trying to sign on with again? Which key file did I generate to join the server? If only there was a really nice way to keep track of these things. Well, you're in luck. If we create a config file, a normal text file, go ahead and start specifying these. So we write host, and then we can write down whatever you want to call it. I'm gonna name it RunPod server thing, and then we'll type in host name. You'll also see I'm getting IntelliSense completions for these. You can also see I'm getting syntax highlighting, so it's a little bit easier to read. This is an extension of VS Code, so if you download and install the remote SSH editing configuration file, you'll get all of these funky features, which I very much enjoy. So yeah, let's open this up again. Host name, that's actually going to be our IP address here. We're gonna go ahead and get the user. Let's see, got that there. And we'll go ahead and type in root. We put in the identity file. Again, remember this is just our private key. And lastly, we put in our port, which is 22040. Awesome. Okay, what does this allow us to do? So now, instead of having to type out that long thing, instead we can just remember, oh, I want to connect to the RunPod server thing. And then we do SSH RunPod server thing. You know, it's a little bit more helpful when you don't have such a long name. But anyways, you do RunPod server thing, and then you are in. As you can see here, there's more properties to play with. But yeah, that allows you to connect really easily. You can also specify the configuration file manually by doing ssh-big F, and then you do SSH, and then you can do config. And it's gonna give me an error, but then I can do RunPod server thing. And then I'll go ahead and use this. The nice thing about that is you could have configuration files located around your computer. I'll get into why you might want to do this. The reason why the SSH daemon wasn't started up originally on RunPod, it normally is. It's accepting like SSH connections. It's because we didn't add any SSH public keys. With our previous instance, you saw we had to authorize keys and put in our public key, and that's a little bit annoying. If only like every single time we started up an instance, we actually had the key already pre-authorized. And that's essentially what this setting does. So you can go back down to the public key, and I'll copy and paste this. And whenever the server first starts up, this is copied and pasted as an authorized keys file, and then this allows you to connect without having to do a lot of the jazz we just did before. It is up, so we'll go to connect. If we go over to the SSH tab, we can see some information has changed here. So let me grab this. So we've got this here. We notice that the IP address changed. Sometimes it will stay the same, specifically with RunPod. The IP address is actually pointing to like a network as opposed to an individual instance, but in this case it did change. Root stays the same. The port changed. And then of course we're still connecting with the same public key, so delete that. So now that should be up to date, and we can see that, yeah, it should be running, and it does actually, funny enough, in the new update, they do tell you whether or not the SSH daemon is running, so that's quite nice. SSH RunPod server thing, we'll say yes, because remember we have a new host name and a new port, so it's just confirming that like this isn't some schemer, some doobaddy. With RunPod, it's important to note that if you were to just stop your instance and then to restart it, it doesn't update the authorized keys. So if I were to go down here, add a new one, then come back over, I would not be able to SSH with that corresponding private key of the key I just added. I would have to like destroy this, I'd have to terminate it, I would start up a new one, and then it will copy over the authorized keys. The copying of the authorized keys happens at the deployment stage and not the restarting stage. And as a final bonus, I'll go ahead and describe how I prefer to set up my SSH config. That makes it a little bit more organized and a little bit more project specific. At this point, if you're working on many projects and you're starting to make one key per project, and also configurations are changing, like for example with the RunPod, you have to very frequently edit your IP address and your port. It's very nice to have this config file in your project itself and not have to go to your home directory and .ssh and .config and go and fiddle with it. My SSH config files will get really long as I accumulate a bunch of things. Also, your keys will start to explode a little bit. Typically when you see people's SSH folders, it tends to be one default key, one default public key, and like the config file. This isn't super great for the same reason why you wouldn't want to reuse the same password, because if someone acquires your SSH key somehow, then they'd have access to every computer that you gave your corresponding public key to. Not fun, not fun. So I like to make a new private key and public key for each project I'm working on, sometimes for different servers individually. So even if I'm working on a front-end server, back-end server, and a database, I sometimes will make like a public key and private key for each one of those. And then I'll have a single config file, which I will set up all my keys into. So just to show you what this looks like, I have in my little SSH tutorial over here, workspaces, lscd, ssh tutorial. I can spell, I promise. All right, yeah, and then we're in project. Right? Nice. Epic even. And I already made this into a GitHub project. Well, I'll make a secrets folder. And with GitHub, especially when you have a public repository, it's really important not to commit your secret files to the public repo. Otherwise, any random person who happens to stumble across your repository will be able to wreak havoc and maybe bankrupt you. So I'll cd into secrets, and we're going to go ahead and do ssh-keygen again. ssh-keygen, let's specify the directory where we want to save this in. We want to save it into this directory, and then we're going to name it, let's name it project name. And then we're going to make sure to use e as encryption type. Is that it? I'm going to also add my quote unquote email. John Joe. Yeah, no, we're going with John Joe. You can ask me for a passphrase. I'm just going to skip this again. There we go. Great. And then we got project name and then project name.pub. I also like to give this the .key name. This way VS Code can identify it as a key. This doesn't change any of the functionality whatsoever. I still reference it the same way, just with a .key instead of no file name. We're going to want to make a config file. Now you'll notice that VS Code doesn't immediately recognize this to be a SSH config file. The normal config file you have in your .ssh directory needs to have no file extension for it to be used. But here, I can use .ssh as the file extension. You don't have to do this, but I like to, and it tells VS Code instantly that this is an SSH configuration file, which you can see up here. You can change whatever, it's just right down here. Otherwise, it would just be on none. Copy this over. RunPod server thing. Now, let's imagine this is for a specific project, right? So I've got my project server, and I've got my host name, user. For identity file, we're just going to use the one that we created in this very directory. So it's going to be project name.key. And And we're going to be using that one instead. Great. And it just all stays the same that way. And then whenever I want to do SSH, remember, I do big F, and I can specify the config file. So I'm already in secrets, /config.ssh. And then we'll do project server. This is going to give an error because I did not add my public key to it yet. Give me a second. I'm going to go ahead and relaunch a new server. I'll give it a name, and I'll go ahead and put in my public key that I just generated into the authorized keys. I went ahead and updated my public keys, and now I've got the example project.pod, so I should be able to connect to that. I also updated the config file. Oops, okay, accidentally edited the wrong config file. I meant to edit the one for the project, which is this one. Anyways, I'm just showing here like how it can get out of hand when you're working on one project and you're working on multiple machines. So for this project, we're running a website. We've got a front-end server, we've got a back-end server, we've got like the database, and then we also have some other server that we're training models with or something like this. This can be really annoying to have to manage alongside of your normal config file. It's also nice to have it as this separate file that you can run with the big F, because you can grab all this, copy it, and you have your friend, and you can send them the host name information, the ports. They'll have to fill it in with like their own identity files, etc. But overall, not too bad. It makes the transfer a little bit easier. I also did not update these to use the actual project name.key. And yeah, let's say that this one here is our RunPod Connect one. So we'll go back over here, copy and paste that, and we'll yoink some of the information from it. Again, okay, so we are not using this key file, actually. We have the one we specified over here. Port we will have to change. IP address also, and root stays the same. So we're gonna go ahead and update that. So we're gonna go ahead and do ssh-config, and we'll run runpod compute. Yes. And then we're in. And so you can manage them all very, very easily. Now, if you don't want to specify the -f either, there's a very nice way to just wrap this into your regular config. I'll go ahead and delete all of these, but this is my .ssh and config file. I don't want to just like copy and paste all these. If you use include, it will essentially import any other SSH config file that you have. Over here, I've got project root, secrets, config, and if I run ssh runpod compute, blammo. We don't even have to specify where the config file is located. Now, one last thing we need to do is make sure that our keys are not pushed to the public repository. How do we do that? With git, you can specify a .getignore file, and in here we can specify, hey, secrets, don't upload anything in it. In the side over here, we can see these all went dark gray. The config file doesn't actually have anything too secret, so we could also say, hey, actually, upload secrets/config.ssh with the little exclamation point here to say, actually, you should do this. And then if we do git add a, so we can see here, we modified the config.ssh from my previous recording, but these are brand new and they're not being added at all. So, and then that's all committed. And so now anyone else who has access to your repository will see which servers you're trying to connect to, which port you're connecting to, how you're connecting to them with root. Maybe this is not the best thing. You might just want to have config.template.ssh. And then you can go ahead and remove all the sensitive information, and then someone else can go and fill it in. But anyways, I hope you enjoyed. This took me way longer than I thought it would. I was expecting to get this done around 6 hours ago or so. Let me know if you have any questions. In the next video, I'm going to talk about how to use VS Code SSH Remote Connect and how that works. Not in quite as much detail as this, but still enough detail where you can understand what is going on.